Does USB version speed matter for input devices? We know that USB V1, V2, V3 has different features and signal/transfer speed. I understand that storage devices will most likely benefit from the speed feature, but does the speed affect input devices such as mouse, keyboard and game controller? I found an old USB hub adapter/splitter which currently I don't know what USB version. I assume it's V1 plus and I doubt if it's V2.0. If I plug it to laptop and plug my input devices to the splitter, is there any noticeable speed difference, like input delay, etc.?
If you don't notice a difference, it might not really matter. You can test your input delay by plugging in the mouse directly and measuring the polling rate. Then measure again through the hub. Look for the download link that says Direct Input Mouse Rate Tool and Mouse P and USB polling rate. There are many online tools that measure polling rate. Here are some Google search results. This URL. Most consumer mice are 125 in NBSP, HZ which is at most a 8 in NBSP, MS delay. Gaming mice might go up to 1000 in NBSP, HZ which would be 1 in NBSP, MS response time. I think at least USB and NBSP 2.0 is required for 1000 in NBSP, HD. 7 in NBSP, MS is not much of a difference. The actual time it takes for a signal to travel from the mouse through the hub and to the computer is likely less than 0.1 in NBSP, as I think the most significant factor is the polling rate, or the hardware in the mouse. Some monitors have an input lag of more than 10 in NBSP, as if you are gaming, a graphics card can take anywhere from 5 in NBSP, MS to 100 in NBSP, MS to display a frame, depending on things like sync buffers and render time.
I expect the cost to be minimal. USB 1.1 was fairly widely popular, and wasn't considered slow for such devices. It was just too slow for certain other types of devices. In many cases, all you need to worry about is the slowest link in the chain, also known as the bottleneck. It doesn't matter how fast other pieces of the communication can happen if there is one point which slows things down. If the mouse cursor feels instantly responsive, and so the slowest point of the communication is the perception of the person interacting with technology that moves at the speed of computer circuitry, then there's no problem. Keyboards really don't need tons of bandwidth. Even the few people who can type over 100 words per minute, like me, are probably only utilizing a bit more than 600 bytes per minute, so any version of USB can handle that with ease. Gamepads that are similarly old will easily be satisfied with such old technology. I'm not quite so sure about some of the newest gamepads, like ones that might also be compatible with modern video game consoles. As for the mouse, you'll likely find that I could believe mouse movement might occasionally lag enough to be noticeable for some people. Certainly it would be within the realm of being quite tolerable for most people, but some people might be slightly annoyed. The bigger impact may actually be how responsive other devices are, such as USB drives or networking devices that may benefit more from increased availability. An example of where that isn't the case is 802.11, also known as wireless. If you have an 802.11 acres device which is backwards compatible with 802.11n and 802.11 grams, and 802.11b and perhaps 802.11a, the slowest of which is 802.11b, that 802.11b support actually really harms 802.11 acres, even if it isn't being used much. The reason is that when the wireless access point does a routine 802.11b check, that requires that the equipment is unavailable for the amount of time it takes to communicate an 802.11b frame. And 802.11b frame takes a lot longer than a faster frame like an 802.11 acres frame, so you could fit multiple 802.11 acres communications in the time it takes for an 802.11b frame. That is a more extreme example. Similarly, An 802.11 grams frame would be faster than 802.11p but slower than 802.11n, and an 802.11n frame would be faster than 802.11 grams but slower than 802.11 acres. So, simply by plugging a USB 1.1 hub in, you might require more bandwidth / processing than some newer technology, using up more time with some motherboard resources. Perhaps the biggest impact would be upon other devices that could be using similar resources on the motherboard, and the most likely culprit may be other USB devices. It might place some circuitry into a slower but more compatible mode, which might have side effects like slowing down transfer speed of a USB drive. Related question: why does Windows 10 assign different port numbers to the same USB port when plugging in 3.0 versus 2.0 device? Graudy's answer shows that different USB controller circuitry gets involved for supporting older devices. In my opinion, what I think is likely is that using such older circuitry is not likely to be more efficient because it distributes the load between multiple controllers. Rather, it is more likely that older communications standards will just slow things down overall, for reasons similar to the Wi-Fi example I described earlier.
The additional delay from a USB hub is of order of tens of microseconds for low-speed hubs and under 1 microsecond for high-speed hubs. Humans don't notice delays less than 100 milliseconds, and in fact many computer screens have a latency as long as 70 milliseconds, which is about 1,000 times longer. So no, a 0.1% increase in total lag because of the USB hub will not matter in practice.
Difference in speed? Yes. Noticeable difference? Probably not. The polling rate of the mouse measures how many times per second, frequency, unit hertz, the mouse reports its relative position to the computer. A higher rate means it reports more frequently. Most mice these days are around 250 nbsp hertz, older mice are usually 125 nbsp hertz. Is the human eye be able to register the difference between a rate of 125 movements per second versus 250 per second? Probably not. Some gaming mice are, or at least advertised to be, 1000 plus nbsp hertz per second. Keep in mind that the higher the frequency, the more CPU power is required to register the signal from the mouse. Or dots per inch is how far your mouse moves across the screen with each movement of the mouse. These are usually options on the mouse. Gaming mice typically have a button you can push to change the P and maybe the color so you know your current P. P is important if you have a high-resolution monitor, 4K, where pixels are so small that moving across 100 of them is a much shorter distance than a low-resolution monitor. On lower resolution, a high P can actually work against the user as one small movement of the mouse can send the cursor flying. Keyboards have a few different measurements for speed, but the difference is so negligible that these speeds are rarely even reported in technical specifications. Like mice, they have a polling rate, but again, differences are almost always negligible, and having a high polling rate keyboard will consume more CPU resources. Keyboards also have a matrix scanning time, 1 in nbsp, ms, 10 in nbsp, ms typically, which is how long it takes for the keyboard to scan all the keys, hardware dependent. If a key is pressed, it stores the key in a temporary buffer. Then an algorithm, 0.5 in nbsp, ms to 10 in nbsp, ms, determines if the event was real, and if so, releases it from the temporary buffer and hands it off to await being sent to the computer, when is determined by the polling rate. Now, to actually answer your question, USB versions have a minimum bus interval, which impacts the theoretical maximum polling rate a peripheral device can have. For example, USB 3.1 has a minimum bus interval of 125 nbsp microsecond, so the theoretical maximum polling rate is 8000 nbsp Hz. Here's what I could find. USB 1.1 and 2.0, low speed. Max polling rate, 125 Hz. USB 2.0, full speed. Max polling rate, 1000 Hz. USB 2.0, high speed, USB 3.0 and USB 3.1. Max polling rate, 8000 Hz. Keep in mind, however, that there are other factors that can impact peripheral performance, such as your operating system and device drivers.
USB 2.0